Hi everyone, and well done again for finding the video. This week we're going to do a bit of a recap of some of the areas of the curriculum that we've not covered for a while. Sequences, we're going to have a look at fractions in context, and we're going to do some angle work. And this is the Getting Secure version. First of all, sequences. Sequences exist when there's some kind of a pattern between the numbers that are presented. So in the first example, we can see the sequences, we're going up in sevens. And so to work out the next number, of course, I'll just need to keep that pattern going and extend the sequence. 23. Equally, if I look at it the other way, I'm going back in sevens. So again, I could complete the sequence in that way. Now, it might be in some sequences are presented differently. For example, it might be I have to count there's 1, 2, 3 jumps between that gap of 12. So I need to split the gap of 12 up into equal jumps of 4, so 7, 11, 15. Or it could be that the sequence isn't changing by the same amount each time, but it's changing in a different way. For example, here, I can see the sequence is going down because it's dividing by 10 each time. Or, again, it might be a pattern of a sequence in dots, for example, and you working out how to continue that pattern. See if you can work out the missing numbers in the sequence. Pause the video. So for the first question, the first thing we've got to do is work out the gap between the numbers in the sequence. And I think it's easiest to work out the gap between the 22 and the 35, 13. So then I'll just need to add 13 here to get me to 48, and add another 13. I would add the 3 first to get to 51, and then the 10 to get to 61. For the second sequence, I know that I'm going up in a step of 7, so of course easy to go this way to get to 18, and a little harder to take away the 7. I know that if I take 4 away, that will get me to 0, and of the 7 I've still got 3 more to take away, so I've taken it all away, so that will get me to -3, to -3. And for the last sequence, I know that 2 jumps is 6. 11 to 17, of course, is 2 jumps, and that's a gap of 6. So that gap of 6, I'll need to split it in half. So each jump is a jump of 3. So 5, 3 more 8, 3 more 11, 3 more 14, 3 more 17. The next thing I want to have a look at is fractions in contexts, or specifically fractions when they're used with measures. So say, for example, I'm looking at 1 3/4 hours, and want to know how many minutes that is. Of course, I know that 1 hour is 60 minutes. 3/4 of an hour, of course, I'm finding there 3/4 of 60, which is 45. So I'd have to do 45, add the 60 to get my 105 minutes. 3/5 of a kilogram. Now again here, I'm looking for the quantity. Well, it's out of 1,000, 3/5 of 1,000. And of course, I just need to divide 1,000 by 5. Denominator to find 1/5, 200, so 3/5 will be 600 grams. Now we're going to have a go at some questions that use fractions within measures. So have a go at these questions using fractions in context. Pause the video. Well, of course, 2 hours is 2 lots of 60 minutes, 120 minutes, and 1/4 of an hour is 1/4 of 60, which is 15. So if I add those together, it'll be 135 minutes. 3/4 of a kilogram, well, a kilogram is 1,000 grams, so I'm looking for 3/4 of it. So I need to divide it into quarters first of all, so I've got 4 250 gram pieces, and I'll need 3 of them, so that will get me to 750 grams. Finally, what's the difference between 1,200 millilitres and 1.5 litres? Well, of course, 1.5 litres will be 1,500 millilitres, as opposed to 1,200 millilitres, so the difference would be 300 millilitres. And finally, angle. There's some basics, of course, to remember with angle. If we're looking at going around a circle, that's an angle of 360 degrees. So I can see that my 3 angles here they've got to add up to 360. Whereas if I'm looking at a straight line, you can see I'm making a shape here almost like a protractor. Those two angles must add up to 180. Of course, angles inside a triangle, this one, and this one, always add up to 180 degrees. And finally, we know that when straight lines cross, the opposite angles, like this one and this one, are actually equal. So that means equally that this angle and this angle must be the same. We'll use these basic facts to answer some angle questions. Now, have a go at these angle questions. So, for the first one, I know that the whole turn must be 360 degrees. I know that this is 90 degrees here. I've got two 50s, so that's 100. So if I add up this bit, and this bit, that's got to make 190. Now, I've got to work out that this must be the rest. So I've got to do 360, take away that 190, and that will leave me with 170 degrees. And of course the obtuse angles are all the angles that are more than 90 degrees and less than 180 degrees. So that one's an acute angle, that one's an acute angle less than 90 degrees, that leaves angle A and angle D. For the final activity, I want you to have a think about the angle between the hands on a clock face. Now, of course, a clock face goes from 12 all the way around, and it will do a 360 degree turn to get back in 1 hour's time. Now, of course, that 360 degree turn is split into the 12 sections. Now, you'll need to work out, to answer these questions, how many degrees each section must be. That's a total turn of 360 degrees, and there's 12 sections. For your final question, I want you to see if you can work out this angle here, the angle between the two hands on a clock face at 4 o'clock. Pause the video and have a go. Well, I hope you managed to work out that if all the way around is 360 degrees, and there's 12 sections, each section must be 30 degrees, because 12 30 degrees makes 360 degrees. And so here we've got 30 degrees, 30 degrees, 30 degrees, and 30 degrees, making this an angle here of 120 degrees. Great stuff. We'll see you back in class.